polynomial. Okay, so there's a lot of different variations of multiplying, and when I say variations, really they're all the same thing, but it just depends on kind of like how many terms I'm multiplying by one another. So the first one is a monomial times some type of polynomial. And so the other polynomial could be a binomial, a trinomial, it could be 3, 4 terms, really doesn't matter, okay? But the one thing that does matter here is that we have one term at the very beginning, okay? No addition or subtraction signs in that first term. So what this is going to look like would be 5x cubed. That would be our monomial. And we're going to multiply it by x squared plus 3x minus 2. What do you think we're going to do here? Any ideas? Distribute, yeah. It's just a basic old distribute problem. We're going to take whatever's in front and we're going to distribute it to all three parts. So that's why it doesn't matter how many terms are in here. It could be 2 terms, 3 terms, 4 terms, 5 terms, whatever, okay? Then we're going to take the one term out in front and we're going to distribute it to everything on the inside. Here's where our exponent rules that we talked about on Friday are going to come into play, though. When I take 5x cubed times, and then this is assumed to be a 1x squared, we're going to multiply 5 and 1 together, which would still be 5. Okay, and then when I multiply x cubed and x squared, what's that going to give me? X to the third and x to the second. X to the fifth, we're just going to add the exponents together. So this would become 5x to the fifth. Okay, so that's where you got to make sure you understand those exponent rules. We're multiplying, but when I multiply, the exponents get added. Okay, then we're going to do 5 times 3, which is 15. And then x cubed, and then this is assumed to be x right here. So that would be x to the fourth. We're going to add 3 and 1. And then 5 times negative 2 would be negative 10x cubed. As I look at the 3 terms that I have here, we have x to the fifth, x to the fourth, and x to the third. All of those are different. None of those can be combined together. So that is our answer. Okay, so that is a monomial times some type of polynomial. Doesn't matter how many terms. Basically, it's just distribute. Okay, the next one is a binomial times a binomial. 2x plus 3 times 3x plus 4. Now, we haven't seen this yet this year, but you've seen this a lot in the past. When I take a binomial times a binomial, there's probably a 4-letter word that you might remember that we have to use when we do this. Foil. Yeah. Just good old foil. Okay. And here's what I will tell you. Every single one of these you really could distribute, right? But if I was going to distribute here, I would have to take 2x times both of these. I would have to take 3 times both of these, which is really a distributive property. But because it's a binomial times a binomial, the way we kind of remember it, or the way you've probably done it in the past, is FOIL. And the F stands for the first 2 terms. So we're going to multiply 2x times 3x. And that would be 6x squared. Okay, the O stands for the outside two terms. Two x times 4 would be 8x. The I stands for the inside two terms. 3 times 3x would be 9x. And then the L stands for the last two terms, which would be 3 times 4, which is 12. Now, before we identify our answer today, then we always want to look at what we get after we multiply and see if there's anything that we can combine together. Are there any like terms in that polynomial? Yeah. We can combine the two middle terms together, and especially when I do FOIL, a lot of times that will be the case where we can combine the 8x and the 9x together. Not every single time, but a lot of times I will be able to combine those together, and that would be our answer. Okay. Obviously, you don't have to write out FOIL every time, but FOIL is just kind of a way to remember first, inside, outside, last, and remember the order. But really, it's just distribute, right? We're taking 2x times both, we're taking 3 times both, and combining all of our terms together. The only time, like if I had 2x plus 3y times 4x minus 5y, you're not going to see this very often, but every once in a while you'll see two variables within this polynomial or binomials, okay? And so this is just another FOIL problem. What I would say here is we're just going to go through FOIL, but because we have x's and y's, that's going to be a little bit different here. So we're going to do 2x times 4x, 2x times a negative 5y. So this is a little bit different. 2 times negative 5 would be negative 10, and you have an x and a y, so that would be xy. 3y times 4x, 12xy. And then 3y times negative 5y is negative 15y squared. Okay, so we got x's and y's all throughout this. And then once again, we look, and like I said, most of the time, the two middle terms, when we do FOIL, are going to be able to combine together. It doesn't happen every single time, but in a lot of cases, we'll be able to combine those together. And then my answer here would be 8x squared. Then we got to really watch your signs. Negative 10 and positive 12 would make a positive 2xy minus 15y squared. Okay. So just good old FOIL. Okay, the next one. We just keep adding more terms here. This one's a binomial times a trinomial. And like I said before, really all of these are just a version of distributing, okay? The very first one we did was just a single term times everything, and then binomial would distribute everything from this parenthesis to that parenthesis. And a binomial and a trinomial are going to be essentially the same thing. We have two terms times three terms. So yesterday we talked about what is a binomial, a trinomial, all that. So now we have two terms here, three terms here. They're separated by plus and minus signs. And like I said, it's really just distribute. So when we do this, we kind of want to organize it a little bit. And so I'm going to take 3x, and I'm going to multiply it by all three things. And let's just start a little bit at a time. So let's do 3x times 4x squared would be 12x cubed. Be careful with your exponents, because x to the first and x to the second. 3x times negative 2x would be negative 6x squared. And then 3x times 1. Okay, then we're going to take this negative 1 and we're going to distribute it to all three. So negative 1 times 4x squared would be negative 4x squared. Now, rather than writing it out as like this big long polynomial, one thing that I like to do, kind of like we did yesterday, is kind of like start stacking these polynomials together. So like things that are together are alike. So when I multiply those together, just to make this a little bit easier, I'm going to stack the x squareds on top of one another. Okay? And you don't have to do it like that. You could write it out as this big long polynomial, but I think it's one thing that kind of makes it a little bit easier. And what you'll start to see is there's most of the time a little bit of a pattern here. Negative 1 times negative 2 is going to be a positive 2x. And then negative 1 times 1 would be negative 1. And then we can combine our terms together. And we're going to get 12x cubed minus 10x squared plus 5x minus 1. So by stacking them, it just kind of makes it easier to see what aligns and what we can combine. Okay. Now, if you don't stack them, that's fine. It's just a way of organizing it more than anything. But you do got to make sure you combine the things together that are alike. That's the most important thing. However you want to go about that. All right, the last couple of examples that we're going to do. The first one, these are just some additional types of multiplying written in a little bit different format. And we got to really be careful of this. And what I would tell you about this one here is this is one that we see a lot, like AccuPlacer at the end of the semester when we take that. This is a pretty common type of question on the AccuPlacer. The reason why it's on there is because it's very commonly missed. A lot of people miss a question like this. You got to be able to do a question like this. And the first thing, when I see something squared, what's that tell me? There's two of them, right? And if you don't write it out as two of them, there's a good chance that you're going to miss this. Because we got to take 3x plus 4, or 3k plus 4, sorry, times itself. If you write it out like this, now we know that it's a FOIL problem. But the most common mistake is people will leave it like this. They don't take the time to rewrite it. And they're going to square the 3k. They're going to square the 4. And they think that's my answer. And they forget the inside and the outside term. Okay. But if I write it out side by side, 3k plus 4 times 3k plus 4, then I identify that as a FOIL problem. And I know I got a FOIL. Okay. So if as long as you write it out, now you know I'm going to have 4 terms. 3k times 3k. 3k times 4. 4 times 3k. 4 times 4. And then we're going to combine the insides together. So we've already done a FOIL problem. So that's not different than anything we've done today. It's just written in a little bit different format. Okay? But take the time to rewrite it. Okay? And I can't stress that enough. If you take the time to rewrite it, I think you'll have a lot more success at that. Okay, I'm going to give you a word here, and you may have seen this word before. I'm pretty sure you have. especially in college algebra, you'll see this from time to time. The word conjugates. Anybody think they've seen that word before? Anybody know what a conjugate is? No way, huh, Shane? Any thoughts on what a conjugate is? Or you guys think you've never heard this word before ever?
Oh, I've heard it.
You've heard it?
Almost on.
Huh?
You were close.
It looks Spanish? Yeah.
Combining.
Not quite combining.
No, I'm right.
Hudson? What do you think? Think you know what a conjugate is? Or you think I've never heard that word before in my life? Okay. And it could be real simple, like if I have x plus 8, and I ask you what the conjugate of x plus 8 is, it's x minus 8. You're getting there? This is a conjugate because it's the same two terms, but we change the sign in between. That's all a conjugate is. Okay? And there's some specific things that happen. If I were to FOIL these together, and that's all it is a FOIL problem. So once again, just a little bit different. Still a FOIL problem, but my answer is going to look a different here because as I FOIL this out, x squared, and then we have minus 8x, we have plus 8x, and then we have minus 64. And then those two are always going to cancel out. If we have conjugates, the two middle terms will always disappear. And all we have left is two terms. Okay. So it's still a FOIL problem, but our answer looks a little bit different. Okay, even if we see one like we did a little bit earlier, if we had x plus 2y, and we have x minus 2y, we're still going to FOIL it. Okay? And it has to be two terms to be a conjugate. So like if you have a trinomial, you don't have a conjugate of a trinomial or a monomial. It's got to be two terms. So we got x squared, and then we have a negative 2xy, a positive 2xy, minus 4y squared. And once again, if we have conjugates, the two middle terms should always disappear, always. And that's all we're left with. That's our answer. Okay, so those last couple are still FOIL, still multiplying, and everything today is just multiplying in a little bit different forms. Should be pretty straightforward lesson today, and that's all we got for notes. Pretty short.
Can I go to the bathroom? Thank you.